Alright, I don't know if you guys can see this, but today we're going to integrate the derivative of 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 the derivative all the way in here to the derivative of x times x squared plus x cubed plus all the way to x raised to the power of 100. Now what are we going to do here? What is our technique here? It's all the way up to 100. Multiplying x all the way to x raised to the power of 100. Now as we know, the loss of exponents says this. Where's my eraser? Oh, there it is. Okay. So the loss of exponents says this. X raised to n multiplied by x raised to n is equals to x raised to n plus n. We know this, right? This will be the loss of exponents we're going to use today. This one over here. X raised to n multiplied by x raised to n is equals to x raised to the power of n plus n. So we're going to use that. So that means this is similar to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 all the way up to 100. Now I want you guys to know how to make this process faster. Okay? So how are we going to make this process faster? So by using Gauss formula. Yes, Gauss formula. Since it's a series from 1 plus 2 all the way to 100, so we're going to use the Gauss formula, which is n plus 1 over 2. It's the same as this series, which is 1 plus, all the way up to 100. We know that. Okay. Moving on. So, let us solve. So, our last number, the last number was 100. So, 100 multiplied by 100 plus 1 is equals to 2. Which then equals to 50, because I've already checked this in a calculator before. And Gus actually did this. When he was a kid, Gus and the rest of his classmates were tasked to get the sum of 100 all the way up, the sum of 1 all the way up to 100. So 1 plus 2 plus 3 plus 4, all the way until plus 100. So let's confirm if I'm correct. I might be wrong, so 50-50. Yeah, see, it's 50-50. Alright, so now we know it's 50-50. Okay, we're making progress. So now we know that it's 50-50 using the Gauss formula. So we could just simplify this. We could just simplify this equation. I mean, not an equation, but we could simplify this to x raised to 50. Oh my lord, I am torturing myself right now. Okay, so in a derivative, we know that f of x equals x raised to the power of n is equals to f, the derivative of x. I mean, n times x raised to the power of n minus 1. Minus 1. Now, I know you probably can't see this anymore, just in case. Okay, now let's move on. Alright, so applying the power rule, we will have, okay, let's take this first derivative. We will slowly eliminate these derivatives because it's so damn many. Okay, let's begin. Derivative of x raised to 50-50. let's do it. 50 times x raised to the 50 minus 1. 50 minus 1 is 5,049. 5,049. Okay, we're making progress there. So erasing this. Now let's erase the first derivative because we already got it. So now let's check the derivative of 50 x raised to the power of 49. No, it was a water bottle, don't worry. Okay, I'm back. Sorry guys, I lost the momentum. Okay, we can continue. Sorry guys, I got a little bit, depressed. I sound depressed right now, but it's fine, so I'm okay. We integrate it. Okay. 8.795181735 times 10 raised to the power of 62 x 5033. Okay, finally. Oh my goodness. So from what I know about integrals is that if we have a constant over here, we're also going to factor this out just like the derivatives. So this multiplied by the integral of x raised to the power of 5,033. Okay. So this, that will be, according to integrals, it will be x raised to the power of 5,033 plus 1 over 5,033 plus 1. Okay. So that will be 5,034. So that will be this, which is 8.795181735 times 10 raised to the power of 62 multiplied by x raised to the power of 534 over 5,034. My bad for saying 534. I think that's what I said. So my bad. It's 5,034. So I think simplifying this would go on the numerator. So this will go on the numerator. So from what I was taught by my buddy, I'm going to divide this by this guy over here. So we're going to do that. So answer divided by 5,034. Okay. So that will be, okay, that will be, so all of this is now equal to finally 1.74715568 8 times 10 raised to the power of 50. Finally. Oh, it was so hard to process. I'm probably wrong, but this is what I got now. Lost the momentum from the first cut. So, that's our answer, guys. Shit, I forgot something. Before I end this video, I forgot something. X raised to the power of 5,034. That's our answer. Actual answer. With X raised to 5,034. I shouldn't forget that. Okay. Or just in case I could be wrong again. I could just rewrite back the initial, like before I try to simplify to this, then it will just be, just in case I need to rewrite this again. That'll be, an alternate will be 8.795,181,735 raised to the power, 10 raised to the power of 62, x 5,034 over 5,034. That's our alternate answer. But it just simplifies to this. So I'm going to have to ask ChatGPT to check if my answer is correct. Because holy moly. How many derivatives did I put in there? Alright guys, that's all for today's video. Make sure to subscribe to Matt Theoxis, because I suffered a lot. Thank you very much. I forgot about that one. I'm so done.